Hi, my name is Sherwin Praveen and this is tech demo number 3. Our first task is to graph the region constrained by 3 surfaces. As you can see, these 2 surfaces already have a bounded constraint. It is this region enclosed here. Our last curve is x equals 0, which splits our region in half. Our constraint is that we only want the negative x value. We want x to only be negative values. The way we can graph this region between here is by setting an inequality. As you can see, that this is the region bounded by the 2 earlier curves. Now we want to split this region in half, getting only the values of x which are negative. The way we can do this is by adding a constraint to our inequality. Now we have only the values of this region when the x values are negative. Next, we are asked to graph the solid region that lies outside the cylinder r equals 1 and between the spheres rho equals square root 2 and rho equals 2. So rho equals square root 2 is given by this small sphere here, and rho equals 2 is given by this slightly larger sphere here. We also have r equals 1, which is the cylinder. We can write this in terms of x's and y's, which is given here. So we want the region that is between these 2 spheres and also outside of this cylinder. The way we can do this is again by writing an inequality. First we will change the rows to in terms of x's and y's. So now we have our 2 spheres, and our region is again in between them and outside the cylinder. The way we can draw this region is we will first begin by giving the region between the 2 spheres by giving an inequality. Now we have the region that is given by these 2 spheres. We can see that this is hollow. The inner sphere is given by our second equation here, and the outer region is the outer curve. The outer shape is given by this third function here. Finally, we're asked to turn this region so it's only outside of this cylinder given here. To add this constraint, we can just include this in our inequality, where x squared plus y squared is only greater than or equal to 1. Now we can see that with this constraint, all the circle with radius 1 values have disappeared because they do not follow this constraint. Now we have a hollow sphere, our region, which is outside the cylinder also. Finally, we are asked to graph the region R2, which is mapped to the square with corners given labeled here, and by the transformation T of u and v given here. What this transformation entails is that x equals u plus v divided by 2 and y equals u minus v divided by 2. We will keep this in mind for later. So our transformation is from u and v to x's and y's. So our points right now are given by x's and y's, so we can draw lines to connect them. These are our 4 lines in terms of x's and y's that were transformed. Now we are trying to find the original function. The way we can do this is by, given the transformation, we can replace x's and y's in terms of u's and v's. Now is our original function given by our original region given by u's and v's. Now we are trying to find the region and trying to visualize this. So we can do this by assuming that this plane in R2, instead of the x-axis, we can imagine the u-axis, and instead of the y-axis, we can imagine the v-axis. So still keep in mind that this function is in terms of u and v, but to visualize it, we will replace the u's and v's with x's and y's just to be able to see it. So all I'm doing right now is, instead of u, I'm writing x, and instead of v, I'm writing y. So here is our original region in the UV plane. The corner points are 1, 1, 1, negative 1, negative 1, negative 1, and negative 1, 1. Thank you.